Alright, so ODP 460 because I wasn't sure where we were in the ODP, so I just picked a new number and started from there. So let's take a look at this. So you're writing a program that processes 2 command line arguments. You've done a bunch of ODPs and other assignments where you processed mostly 1 command line argument or 0. This is almost exactly the same thing, except you're going to use argv bracket 1 and argv bracket 2, right? So if you're making a program called ODP 460 and you give it a pair of numbers, right? This is always contained in element 0 of your argv array. This is our usual argv bracket 1, this is your argv bracket 2, and if this is exactly the way the person ran the program with 1, 2, 3 things on the command line, argc will be equal to 3. So your goal is to write a program that basically lets you say something like ODP 460 followed by 2 integers, and it just prints out their sum. And if there's anything that goes wrong, you're just supposed to print the word ERR with a new line. So what can go wrong? If argc is not 3, print an error and you're done, right? Don't look at these things if argc is not 3. So your first thing you want to check is argc equal to 3. If it's not, print an error and exit. Okay. If argc is 3, then you can go ahead and you can try to see if these 2 things, argv bracket 1 and bracket 2, are integers. How do you know that? Use scanf, right? And exactly the same thing we've been doing since we started this. So for example, you could scan argv bracket 1 with a %d followed by a %s. Put that thing into, you know, a number 1 and then have an extra array and make that, you know, a big character array.
And overload scanf again to get a third argument in there.
To get a third argument, well, you've only got 1 argument in here.
Oh, okay.
Right, so argv bracket 1 is just going to be 1 integer. And then you're going to do this again for argv bracket 2. So for 1 integer, you scan this with a %d, %s, and if this is an integer, it will go into, you know, in this case, n1. But you don't know if you got an integer or an error unless you check the return value from scanf. So you can save that in something like, you know, return 1, and then if return 1 is not equal to 1, that's an error. Print out your error message and exit. You don't even have to look at argv bracket 2. So think about, you know, sequences of steps. Think about algorithms, right? If this is not 3, you don't have to do anything else. You know it's an error, you're done. If it's 3 and you scan this and you don't get back a 1 from scanf, there's something wrong with this first number, you're done. Don't even worry about the second one. If this does return a 1, then go ahead and scan argv bracket 2, put that into, you know, maybe n2, some other variable. Check the return value. If it's not 1, that's an error. If you get through all of that and you don't have any errors, now you can take, you know, n1 plus n2 and print that out with the %d \n in a printf. And so if all this works, you know, if you run this command with 2 integers, it should give you the sum, 47 in this case. If you have extra stuff, it should be an error. If you don't have enough stuff, if you don't have anything, that should be an error. If you have, you know, something that's not an integer, right? Anything that's slightly funny, that's an error. But if it's exactly 2 integers, print their sum and return. So that's what your function should do, and then just go ahead and assess it. All right, do an attendance ping, please. And let's take a look at Canvas. So I uploaded a VI editor quick reference chart. I looked around. I found a bunch of these online. They're easy to Google, but this one was small and seemed to have a lot of good stuff on it. It's probably the cleanest looking one of all of them that I saw. And I mean that's it. It's just one page, but it's got the stuff about saving and exiting, um, moving around by words, undo, search, which we're going to talk about today. Basic movement, right? So moving around up, down, left, right, going to the beginning or end of the line, using words, going backwards by words, and so on and so forth. Deleting, which we talked about, so X, DW, DD, and Shift D. And we're going to talk about inserting, so add and append, and putting in new lines. We'll talk about that today, along with changing text and then copy and paste. So that's just one reference that if you want like a one pager. But I would suggest maybe keep this handy and use it to start. But go ahead and just start a cheat sheet on your own and scribble down the things that catch your attention and that you tend to use, and build up your own reference card along the way. All right, so let's keep digging into VI. So let me hop out of here. Let's see. So chat message. This is worth mentioning in here. So, here I'm taking the return value from scanf and I'm saving it in an integer. We don't really have to do that, right? The only reason we're saving this in an integer is to know if this scan returns a 1 or not. So you could actually do something like, if 1 is not equal to scanf argv bracket 1. Right? And this if statement does multiple things. The first thing it does is it calls scanf. Scanf will, save something in N1 if there's an integer and save something in extra if there's extra stuff. And then this will check to see if the result from scanf differs from 1. And if it does, then it will do whatever we put inside the curly brackets, which would be, print out the word error and return. And so you can do a single line here to do that scanf. Or, you could do if 1 equals scanf argv bracket 1, or 1 is not equal to scanf argv bracket 2. You could do the whole thing in one line, right? And that's all legal. That's what C is meant to do, right? You can put these blocks together any way that you like. So I've tended to do it like this, just to sort of break things out into steps to make it easier to talk about each step. But you can definitely combine these and make your code a little slimmer. All right, let's see, VI. So here's my test file, and where did we leave off with VI gizmos? We were moving around, we were deleting, we did some miscellaneous. So inserting. So most people use the I command to enter insert mode. And that's perfectly fine. I can come down here and say I to go into insert mode, and I can say this thing is not running. Right? And the hard habit to get into is when you're done inserting, hit an escape. Right? So that now if I want to move around, I can use my JHKL, I can DD to delete a line and U to undo and so on. But you gotta get in this mindset of like when you're done inserting, hit escape. Go back into command mode. So we can do an I to go ahead and start inserting. One thing that's tricky is if you want to add to the end of a line, right? If I type an I and I start typing, it goes before the G. The command A is for append. That will start adding after the current position. So I can, don't do anything else here. So A is useful. And then sometimes you want to start an entirely new line. And you can go back to the beginning of a line and say I and hit an enter, right? But if I'm just like sitting out here and I realize I want to put a line, before this, I can hit a Shift O, and that will open up a new line above where I am, and I can start typing there. And a Shift O opens that up. And a lowercase o opens a line below your current location. And you can start typing there. And you don't have to be at the beginning of the line or the end. You could be anywhere, in the middle, and just do an O to open a new line below. All right, you can replace a single character. So if I wanted to replace this H with an uppercase H, I could hit a lowercase r, which means replace. The next character I type will take the place of that. So if I hit an uppercase H, it changes that to history. If I want to change this to a 2, I can type an R and hit a 2. So that's easy. If I want to replace a bunch of text, like when you go out of insert mode in Notepad, where everything you type just overwrites, the way to do that is an uppercase R. So if I type an uppercase R, now I'm overwriting whatever was previously on this line. And that can be useful sometimes. And then probably the most useful way to make changes is CW, which is change word. So we've got DW, which is delete word. And if I wanted to change history to story, right, I could delete word, I could insert story, and then I could escape. But I can also just say CW. CW will show me where the end of this word is, and then I can, type whatever I want, and it'll replace that word. So CW is useful, and those are the main gizmos for editing text. I would say everything that we go over up through and including tomorrow is fair game for the midterm. So ODP 413, but also ODP 460. If I give you an ODP tomorrow, that will not be midterm material because we won't have talked about it until Monday. So, but ODP 460 is still fair game. All right, let's see, what else can we do? Oh, tilde is a useful command. So if you do a tilde, it changes between uppercase and lowercase. So if I just start hitting tilde, it just changes all my lowercase to uppercase and my uppercase to lowercase. And you can put numbers in front of that, so I could do 100 tilde, and everything on that line changes case, and then U will undo it, so I can do my dancing text. All right, so that's the main stuff for modification of text, either inserting new text or changing existing text. So searching. And searching is really useful. Easiest way to search, just type a slash. So let's say I want to find where I echo something. I can type a slash followed by the word echo, and that will show me the next place in my file where that string appears, which is right here, echo terminal. If I want to search for that same pattern again, I can just hit the letter N, and that'll take me to the next occurrence of echo. And I can keep doing this, and every time I hit N, it takes me to another occurrence of this. And then when you get to the bottom and there's no other occurrence, it will give you a message saying search hit the bottom, continuing at the top. So slash anything searches for that, and then N will repeat the search. And then if you want to search in the other direction, you can do a question mark. So if I do question mark this, it'll actually move up. It's hard to tell here. Do question mark color, so that moves right there. And if I do an N to repeat that search, it'll go back to the previous occurrence of color, and it keeps searching up. So if you search too far and you want to go backwards, you can also do a shift N to search for the next occurrence of your pattern, but in the opposite direction. That's a detail. Basically slash and N are the ones you want to know there.
I've heard that there's a lot of plugins you can get for Vim.
There are.
I was wondering if there's like some for, say, in IntelliSense, like I'll type in a word that looks similar to this variable I have, and I can just hit tab and finish typing it.
I think there probably are. I haven't tried any of those, but I can't imagine that that's not an available plugin, because that's what most IDEs do. But yeah, go ahead and Google that one. And if you find cool stuff, right, you're encouraged to pop that in Discord, tell people about it.
What's the command for next word again? Just B for back, one word.
So the next word would be W, just a lowercase w. Yeah, so if I'm in here, W goes forward. And you can delete a word with DW, you can change a word with CW. And you can go backwards with B. Alright, so there's a whole command line environment inside VI. We actually access this when we exit. When you say :W, for example, right? This colon is something different. We're down at the bottom of our window, and VI won't do anything until we hit enter. So if we say :W, that writes the file. But there's other things we can do. So for example, set number to turn your line numbering on. Syntax on or syntax off, and so on. But there's other things we can do. So for example, we could say, well, let me get out of here first, and let me make some more files. Alright, so there's a kind of goofy looking comment block that you can do in ASCII text. Whatever. So you could write text in here. And let's say you have a standard, way that you like to do ASCII text to list your name and the date and the class number and stuff like that. And I'm going to put this in a file called header, right? So if I'm working on a file and I want to read in another file into this file, what can I do? Well, let me open a line up here, and I want to read right at this spot. So I'm going to say :r space and the name of a file, and it'll pull in all that text for me. And now I can, clean it up and add some extra space and so on and so forth. So if you've got stuff that you use a lot that you want to store in one file, but then pull it into your main file, you can do :r. You can also do :w. So maybe this section of code, maybe these next 5 lines are really good code that I want to save somewhere. So I can say : dot comma dot +4 write save me. And that gives me a new file called save me. And if I look, there's my save me file, and it's got those 5 lines that I just saved. And you can edit multiple files, so I can do vi test save me. And so here's my test file. And if I say :n for next, it'll go to the next file. If I say :n for next, it'll tell me there's no more files. I'm at the last one. And then really quirky, I don't know why this is, Control-6 will shift between your last 2 files. So right now I'm looking at save me. If I just hit Control-6, that takes me back to test. If I hit it again, it takes me to save me. And that's surprisingly useful. So let me clean up my header here, right? I'd like to save this in my header file. So I can also say : from line 1 to the current line, 1 comma $. Let's write that into my header file. And it's going to warn me the header file already exists, so I need an exclamation mark. So 1 comma dot write into header. So there's my header. And if I do Control-6, I can go into that file and see what that looks like. So you can bounce around between files pretty easily. You can also use this colon business to do larger scale modifications on your file. So for example, I can do Control-G. This is line 9, and maybe down here is line 50. And I want to get rid of all of the lines between 9 and 50. I can say : 9 comma 50 delete. And it gets rid of all of those lines. And if that was a mistake, of course, I can undo. Alright, we can also execute commands, so I can say : date to see what the date is. And it just, temporarily leaves VI, runs this command, shows me the results, and then when I hit enter, I go back into my file.
It's super great for automating stuff.
It is. So let's say I'm writing my code and I want to say, this is the main code written on, and I want to put a date in here, right? I can say : read exclamation mark and type a Unix command. And this will run the command, but it will capture the output, and whatever the output is will get added to my file right below my current location. So I say $! This should run the date command, and it puts the date onto that next line. Now I do a K to go up, a Shift J to join, and I've got my timestamp inside my file. Do an O to put a blank line at the bottom, and there you go.
Is there a way to edit VI so that every time you VI a new file, it adds a couple lines of code at the top of it?
Probably. I think you might be able to put that in a vimrc, but you can also make macros, and you could hardwire a macro. So you could say, :map and exclamation mark to 1G, open up a line. This is my header. I want to record an enter key as part of this macro command, but if I hit enter, it's going to end my command. So there's a escape character, Control V. If I hit Control V, the next character will be taken literally. So I hit an enter, and that becomes, part of my command. So my exclamation mark is going to execute the command 1G to go to the top of the file, and then open a line above, say this is my header, and then say hello, and then let's do one more line, end of header. And then I want to hit an escape to take me out of the insert mode that I entered when I did the O, so I'll do a Control V escape. I don't know if it's going to work or not. So, so let's do that. So now if I'm sitting down here in my file and I just hit an exclamation mark, it just added that header to the beginning of my file. And so I think you could probably put that into an initialization file. If not, you could just record that macro, and when you start a file, just do an exclamation mark or add a bunch of headers by hitting exclamation mark repeatedly. So that is the boundary of my personal, VI skills is using macros like that. Once in a while, though, it's a real time saver. If you've got some large set of changes you need to make for your file, or something that you want to do a bunch of times that involves the same keystrokes over and over and over again, it's pretty easy to just make a macro. And so that's :map, and then this character that you want to use to invoke the macro, and then the keystrokes that you want that macro to expand to. Alright, so that's macros. And then there's command line searching. And this is a much bigger topic, and we'll spend some time later in the course digging into what are called regular expressions. But a regular expression is basically a really fancy, sophisticated wildcard system, so that we can do wildcarded searches and such. And in addition to searching, so I could search. Well, I'm not going to cobble something. In addition to searching, well, let's do this. Let's search for. Let's search for an equal sign followed by a digit. Okay, this is a simple regular expression. Simple in the universe of regular expressions. This is looking for the character equal sign. The bracket says look for anything between a 0 and a 9. So this should search for any line where I'm assigning something a numeric value, right? So there's where I set my hist size to 1,000, my file size to 2,000, my error to 0, 1, and so on, right? But it's not finding these patterns where I say, something equals auto, which is not a digit. So that's an example of a regular expression, but we can also do substitutions. So I could say substitute substitute / export / import. Import, right? And on this current line, if it finds the string export, it'll replace it with import, which is not a bash command, but that's okay. If I wanted to do that multiple places, I could say, from the beginning of the file, that's line 1, to $, that's the end of the file. Substitute export with import. And it made 10 substitutions, and everywhere that it said export, now it says import. If I wanted to change my script so that when I want to set up an alias like this, I use some other command which records this in, I don't know, a text file that I can use to search for aliases or something, right? I might want to change all occurrences of alias to my alias, right? So I could say substitute alias, my alias, and all of those got changed. And it's a whole nother lecture to really dig into what regular expressions are and how we can use these to do more sophisticated substitutions and searches, but about half of what I do in VI seems to be regular expression based substitutions. Everything that I do as a teacher, as far as manipulating grades, tracking attendance, stuff like that, is all this kind of stuff. It's all just regular expression commands. So I can download a list of students from Canvas, and they come in as first name, last name, and I can easily change it to be last name, comma, space, first name, or first initial followed by last name to get your Linux ID. And I can convert them to lowercase because in Canvas your names start with uppercase letters usually, and all this stuff, right? And you can do all of this inside VI. And we'll have to talk about regular expressions to really kind of unlock that. But that's another reason why this is a good environment to be working in, because you have all of that machinery available for you. So we'll come back to that in a few weeks when we talk about regular expressions and grep. So the last thing is vimrc and exrc, right? These are initialization files. And so, for example, I map an exclamation mark to a public static void main paren, right? I map a back quote to a system.out.println. Because when I'm teaching 223, typically we have to type these lines in over and over and over again, right? So if I want to define a class, and I want to make a public static void main, I just hit an exclamation mark. But I'm on a different version of VI, but it works on the Linux server. So you can put customizations into exrc and vimrc.
Like snippets?
Yeah, like things that you might type when you're inside VI, like turning on color coding or turning on bolding, or changing it so that instead of making a bell sound, it flashes at you, a visual bell, and different commands will set these things up. Well, you can put all of those commands into this vimrc file, and they'll get executed every time that VI starts. Just like whatever you put in .bashrc gets executed every time that bash starts. That's why when you log in, the stuff in your bashrc runs, and you get your aliases and symbols and stuff like that. All right. Any other questions? Like I say, this is not something I'm going to test you on. It's stuff that if it's useful to you, that's great. But hopefully, if nothing else, it lets you know that there's a lot more you can do in VI than just move around and use backspace and type, and try these things out as you work. And when you stumble across something that saves you some time, if you encounter that situation a lot, you'll probably start using it more and more, and it becomes just sort of part of the way you work in this environment. All right, let's do a mid-class attendance ping. Let's talk about GDB. So, debugging, right? You're writing C code, it doesn't work right. We've talked about how you can put print statements in your code to help know where you are in the program and so on and so forth. That works for small programs, but you have to put the print statements in. Sometimes the print statements introduce bugs. Sometimes adding a print statement will make a bug go away. and that's really unfortunate because it makes it harder to debug. And sometimes you put in print statements and you forget to take them out, or you take them out and you take out too many things in the process and your code ends up breaking again. And it's not ideal, right? So we're going to talk a little bit about this thing called GDB. This is the GNU debugger. So a bug is something in your program that you didn't intend to have in there and that causes some kind of problem. And so debugging is the process of finding those bugs and removing them. And let me tell you something that you'll hear me say a lot over the next year, which is when you find a bug, don't just delete your code and start over again. Don't just start randomly changing things to try to make the bug go away. If you're writing mindfully, right, if you feel like you know how to write code to do something, and you write your code and it doesn't do what you wanted it to, right, that is a huge learning opportunity. Right there, you've got something that is not quite the way that you think it is. Something that works a little differently, something you forgot, something that you need to figure out. And if you just, rewrite your code or Google it and find out how to fix it or start changing things until it works, you've lost this learning opportunity. You've lost a chance to pin down what it is that you're misunderstanding or not completely understanding and resolve that. So when you find a bug, you really, really want to explore it, right? Save that code. If you're against a deadline and you just want to change things so you can get it turned in, okay, but save that buggy code and go back to it later. And the worse the bug, the greater the learning experience, right? A bug that you look at and you say, oh, I forgot a semicolon. Okay, well, you learned not to forget a semicolon. You knew that already. A bug that you hit your head against for 3 hours before you figure it out, there's something more major going on, and the aha moment, the brilliance of that flash of light when you figure it out is going to be greater.
Still a semicolon.
Still a semicolon. So my worst bug ever was about 2 weeks, and I spent 2 weeks, probably about 8 hours a day, tracking down this bug before I found it. And it was something subtle, and it was something that changed the way I think about a certain aspect of programming. And it was just every day, just stepping through my program one line at a time, until I found something that didn't make sense. But it was a huge aha moment, right? And those, like I say, they're really good learning opportunities. Better than ODPs, better than programming assignments, right? Because they're very specific to something that you are trying to figure out. So GDB is a great way. Oh man, that's harsh. Someone said mine was about 4 weeks long and it was a misspelling in a dictionary. That's brutal. So GDB is a nice way that we can dig into our program and see what it's doing. And strictly speaking, we don't need GDB, right? So there's this idea of pretending you're a computer. And if you've got a program and it's supposed to do X, but it's doing Y, you don't need a debugger. You don't even need a computer to figure that out. Theoretically, you look at your code and you pretend you're the computer. So if it says integer I equals 0, you write down, I equals 0. And if it says integer x comma y, you write down x and y. But if you haven't initialized them, you say they're equal to question mark. And then when it says, x equals x plus 1, you say, well, I don't know what x is, so x is still a question mark. And then when you say, if I equals x, it's clear, I'm comparing 0 to something I don't know the value of. Hey, I forgot to initialize x, right? It's usually not that straightforward. But you can basically do what you believe the computer will be doing, step by step, right? If it says do this arithmetic expression, do that arithmetic expression and update your variables. If it says call a function, put this piece of paper aside, start a new piece of paper for your new function. Write down what the arguments are, And if your argument is called temp, write down temp equals whatever you passed it from the caller. Go through your function. If there's a return value, come back here, and where you called the function, replace that with the return value from the function, and continue. And eventually, you'll find an error. And you'll say, oh, I forgot to return my value, or I returned the wrong variable, or, I checked the return value inside my loop, it should have been outside, or something. But this is easier to say than to do. The challenge with doing this is primarily doing it faithfully. So this is like trying to proofread an essay that you've spent hours writing, and you've been reading it while you're writing it, and then you try to proofread it to look for errors, right? Well, when your eyes scan over the page, you're not actually reading it. You're recalling what you wrote. And so there can be a glaring typo or a sentence that isn't formed correctly, and you'll just skip right over it because you're not actually reading it, you're not actually seeing it, you're recalling what you think you wrote. Well, the same thing happens with programming. If I say something like, if x is equal to 5, do some stuff, and hardest bug in the world to find, because x equals sine 5 is not doing a conditional comparison. It's setting x equal to 5, and then this expression is true. So if x is 0, this statement still gets executed, and at the end, x is equal to 5. Really hard bug to find. So if I'm staring at my code, and I get to this, and I know that, x is equal to 0, I'm going to look at this and say, nope, I'm not going to execute this loop because x is not 5, right? And I'll skip over it. I'm not actually seeing what this does. So this is where GDB can come in. GDB will execute your code, if you like, one line at a time, one statement at a time. It will let you look at the values of variables. It will also let you change the values of variables. It will let you look at your source code. It lets you basically do what you do when you try to pretend you're a computer, except it is a computer. So it won't make these kinds of mistakes. If x is 0 and it sees this statement, it will set x equal to 5 and start executing this loop. And as you're stepping through it, if you're stepping it one line at a time, you get down here and you're thinking, okay, x is 0, it should skip this. You say, do the next instruction, and it's doing this instruction inside here. Now you got it, right? You're like, wait a minute, why is it executing this when x is not 0? So now you print the value of x and you see it's 5. And you say, wait, I just checked x, it was 0. How did it change to 5? And then you're going to see it. It's going to be like, I can't believe I did that again, right? Should have been a double equal sign. So you go out, you change the code, you recompile, you retest it. Maybe it works. Maybe you've got a different bug. You go back into GDB and do it again. Debugging is a big part of programming. Time-wise, it can be, a significant percentage of the time you spend. Because when you get really good at writing code, right, when you've been writing code for 10,000 hours of your life, right, you can sit down and you just bang it out on a keyboard, right, without even thinking. But debugging always takes time, right, because they're mistakes. And you can get faster at debugging, but you almost always have to spend time doing that part of it, testing your code and finding the errors and then correcting them. So this is like a really, really important skill. This is one of the skills that people will see you as being super valuable to a team because of your debugging skills. So we'll talk about GDB in some detail tomorrow. We're still talking about it today, but we're almost out of time. But we'll talk about GDB in detail tomorrow. I'll give you some of the basic commands, and we'll play around with some code with some bugs in it and step through it with GDB and get a feel for how we can use this. And GDB, like VI, like Unix, like everything else, right, is huge. You can do so many things with it. You can customize it. You can create your own commands. You can work in all these different modes, right? And I know about 8 or 9 GDB commands. That's it, right? But it's enough for you to be able to debug most code. Now, if you want to do fancier debugging, if you want to do a lot of debugging in some particular environment, You might want to customize things, make some macros, all this kind of stuff, right? But we can get started and we can be very efficient with this debugger with just a small set of commands, half dozen commands. So we'll talk about those tomorrow and start playing around with this. And then we'll talk about PA3 tomorrow, which will be another C program. And I will invite you, while you're working on that next program, to be playing around with some of this stuff, right? Think about maybe using VI a little differently. Think about using GDB instead of print statements when you get stuck trying to find a bug and so on. And so we'll do some kind of hands-on experience with these tools through PA3 and through the rest of the course, actually. And then when we get to 222 in winter, GDB is going to be your best friend, because we're going to be doing things that are really hard to do with just print statements, because we're going to be creating structures in memory on the fly. We're not going to have variables we can just print. We're really going to need to follow memory around and see what memory is set up with. And GDB is going to be the way to do that. Yeah, PA3 I said I'm going to post later on today, probably tonight. So details will be available tonight, and we'll talk about it in class tomorrow. And it'll be a C program. Alright, we're good to go. Give me an attendance note on the way out. Yeah, dynamically allocated variables, excellent. Do you know what the last check for ODP 460 is looking for? I probably do. Test ODP 460. Test all the possible errors that you can think of. So, if you do a 2 and a 3, you should get a 5. If you do a 2.1 and a 3, you should get an error. If you do a 2 and a 3 and a 4, error, 2, error, ha, error, 2, ha, 3, error, ha, 3, error, right? So we went through a bunch of these in the beginning. You go back and rewatch the video. I think I hit all of the major test cases in the beginning when I ran through a sample of the executable. Alright, cool. We're out of here. I'm on to my next section. Have a great afternoon. I'll see you in 2:15, or I'll see you tomorrow.
Have a great day.
Thanks, you too.